Hi, in this short video I will demonstrate how the first exercise is actually running as a simulation to start with, and then you can go through the different parts to create the model, the exercise one, making the programs, get it running, and yeah, let's see then how it looks like. So I opened this one, I prepared it before and did it, and then in the next videos I will show how to create it, and then we see how it goes. So uh, I think I have one in maybe this one. Yes, good. Um, that is the one. So we have the robot up. Now to familiarize ourselves with the interface. So if I right click here on the tool or on this one, right click, view center, I redefine what I am rotating around. If I click control and the left mouse, I can pan around. If I use the middle mouse wheel, I can zoom in out. If I use Control Shift left click, I can rotate around the viewpoint that I just selected. If I totally get lost somewhere, don't know where I am, I can right click View All. Then I am back in a way, more or less like this. Okay, so, and the robot station looks exactly the same in the Epic Lab, in the physical robot. I will try to fix a video shooting of the physical station at a later stage, but we have this front table, the left table seen from the robot, the right table seen from the robot, and there are some frames actually located here, and those are calibrated frames and should never be moved. But if we look at those in the home tab and that with the paths and targets, so those are actually included here in this station. So we have work objects and targets, and if we look at that, that is active. You can see here work object left table is active, and the tool is a CAD tool, which is this one here. But anyway, we go to this one here and click on that one, which is boldface, and right click on this one and modify work object. And then we can see on the user frame the values of this one. It has some values, and those values represent actually the position of that relating to the base of the robot. And those are calibrated beforehand. That is taken care of, so to say. So that is something we don't change. And for this exercise we don't change anything. But for a later exercise, we do change the object frame. So this is actually the position and orientation of this frame here. And then we can have an added object frame somewhere on the table, anywhere, at any place, and that can be that will be called the object frame here, where we can put new values in relation to the user frame defined here. But that will be done in a later exercise. So anyway, I mean, for this first one, we have simplified things, make it more simple to understand, because the complexity of the tool is quite big to get some understanding. So we run a simulation and see how it runs. Go more in detail. Do like this, but we just stop it. So I click on that one, do something, so we can get it more detail. So it is roughly a millimeter down in the pocket here, or whatever we call it. The plate is of aluminum. maybe 400. And it is programmed to run in this. And we have a set of targets here in that, paths and targets. And well, you can see how they move around like this one. And what we can do is, if we right click on a target, we can view the robot as at the target, like this one. Or some view about how it looks like. And then we can move around like this. So there are many ways to actually look at that solution, how it works, and so forth. Stop. We have a TCP trace, so we can see actually how the tool is moving. Enable TCP trace, and we can use primary color, red, for example, easily visible. That, and we play like that. Good. Now we can see here that if we go details into the corners, it really doesn't go into the corner. How come? Why is it like that? Well, we have to look at the program. So if we go to the Rapid program, the tab here with the Rapid, and open up the Rapid part here, and double click on module 1. So the program is actually connected to two containers. One is the main module, one is the module where things are actually happening. Because in the main module, if I double click that, it just is a main part, a main procedure that kicks the ball, gets the ball rolling, so to say. And that calls path _ 10. That is in module 1. So here we have procedure path 10. A number of targets, no logics, super simple. So we have a few parts here. We have target 10, 20, 30, 40, and so forth. And those are robot targets with coordinates. So nothing special with that. That is what the robot is going through. Then we have a velocity, 1000 millimeters per second in the beginning, then 500, and in the path, 100 millimeters per second. We will change that soon. And then we have something that is called Z, Z100, Z10, Z1. And that is a zone. I will go through that at a later lecture video. But in principle, it is that when it has reached the target position within 1 millimeter, it will start to go to the next target point. So if we do like this, that we do some changes here. We can click on Rapid Path Editor on that one. It opens up a double window like this one, and we use the same mouse button as before, the middle wheel to zoom, and control to pan, like that one. And if you click on one of those, for example that one, maybe the one before, that one, perfect. And then we change 50, Z50. So you see that now it applies the zone 50 millimeter. So it will round that, and obviously that will create a collision. That is for sure. 5, Oh, like that. 5 millimeter. And if we do like this, take it back to 1. And now we can apply find and replace, like this one. Find, replace, replace. So we change all Z1, replace it with fine. Fine is a full stop. Replace. Replace all. That was not intended actually, because we got a problem here. Z100 at 100 Z10, and in the end we needed to have Z10 Z100 and Z100, like that. Okay, so if we now do an apply all changes and check the output here, you see that there's no errors. And now to apply this to the simulation, which is related also to the station, we have to synchronize this program, this rapid language program, from the controller, because it is the controller that actually executes the program, to the station. So we do synchronization to the station, click on everything, and OK. It is completed. And click on simulation, and then we run it again. And now it should be a full stop at every corner. Like that. So this is actually the way to change the behavior. Another thing to think about is that we have the possibility to check collisions. If you we have a collision queue active. I will tell you how to manipulate that later on. But if you right click on that one, it is active. Modify collision set. So we have a near miss value that now is 0 that can be changed. We can set that to 1 millimeter, for example, so it will indicate when it has a near miss at 1 millimeter. And the color will be yellow. Collision color is red. Apply. Close. We run this now. Now, if we do like this, that we actually edit this program and change fine to something else, we do replace. Replace. Fine with, for example, Z5. So it will round it, replace all, like that one. Apply. And synchronize to the station. And then we run the simulation. So we have a near miss because it is rounding quite heavily, but it is not a collision. It is not saying that anyway. And what can we do? Okay, we just continue. And in the same way, we can also detect collisions, of course. Okay, and a final thing also related to this one. I think we turn off the collision set at the moment, so it is not active now. Collision sets consumes computer power. It will slow down everything. We have a stopwatch. If you make that active, so we click on stopwatch here, and we have a simulation start, simulation stop, and then we can check, how fast it runs. So we have 15.24 seconds. So quite um, obvious. If we edit this program here, can delete that one. If we edit the program, change the velocity, for example, well, things will speed up, of course. So what we can do is actually to change. We just make a repeat 100 comma with the 300 comma will look like this. So we have 1,000 in the beginning, and we apply it to everything, apply all, check the output here, so everything is fine, no errors, good. Synchronize to the station, and like that, begin everything, just to be sure everything works, run the simulation. So we get the new timing for this one. Should be much faster, of course. So now we have 7.488, less than half of the time before. So this is just a quick run to see how things works in this exercise when we are finished. Okay, bye for now.